got dy by dx is...
The beginning, so.
Have you only just started recording?
No.
It's on the bar, isn't it?
Right. Dy by dx is v times dy by dx, so v x cubed minus 4x squared plus 2 times du by dx, which would just be 3, minus u, 3x plus 4 times dv by dx, which would be 3x squared minus 8x. We differentiate the bottom, all divided by v squared, and then all divided by v squared. And there we are. And actually, having just said that thing about trying to factorise things, it's looking to me like we haven't got a common factor here, have we? There's no real alternative but to do some multiplying out and see what we end up with.
Did you just leave it like that in the
Find an expression for dy by dx and show that the x coordinate is
Yeah,
satisfied.
technically that is dy by dx.
It is an expression for dy by dx. Yeah, you've done it. We're going to have to do some more with it, aren't we? Because we're going to need to work with dy by dx being 0 and rearrange it to get something more sensible. But you're right, we took the first bit. What have we got? We've got 3x cubed minus 12x squared plus 6. And then we've got minus 9x cubed plus 24x squared minus 12x squared. I've run out of space.
No, that's great.
Computer. Plus 32x all over this denominator. So what have we got?
4
We've got
times 8 to be 24.
minus 6x cubed minus 12 plus 24.
You can't cancel it.
There are no x squares. We agree with that?
Yeah.
Plus 32x.
It's 25 squared.
There's 2 minus 12s.
Oh yeah.
Where's the 24x squared?
Yeah, very happy. The x squared. Got plus 24 minus 12 minus 12. Okay, well, before we get too much further into this, what we're supposed to be doing with this is getting an expression that happens at the stationary point. So let's go straight to that at the stationary point.
Flip that. Yeah, it doesn't flip.
Which is called P. Dy by dx is 0.
So, no.
And if dy by dx is 0, then of course with the fraction that doesn't mean anything about the bottom line. The bottom line can't be 0. So if dy by dx is 0, it's only the top that needs to be 0. So we're saying that minus 6x cubed plus 32x plus 6 equals 0. And what we need to do with this, we don't need to solve this at this point. We're supposed to be heading towards that equation there, x equals the cube root of something. So that looks to me as though we've got the cube root, we've got x cubed on its own, and then cube rooted everything. So let's rearrange this so we can get x cubed on its own. We've got 32x plus 6 is 6x cubed. If we divide by the 6, we've got 32 over 6, which we could write as being 16 over 3, plus 1 is x cubed. And if we cube root, we've got 16 over 3x plus 1, so we've got what we hoped for.
I've got some fish for our
Why is when this is
5 minutes of fame.
I would like to have just kissed him on the face. Let's do an impersonation of Camilla's videoing.
No, just said you were really great at maths and film.
Right. Where was that? Oh, we've done it. Yeah, right, we've done that bit. The next part of the question. Come on, we'll get back to this. The next part says, by first using an iterative process based on the equation in part 1, find the coordinates of the giving each coordinate correct to 3 decimal places. Let's go. How do we know what to start with?
What?
It's there, isn't it? It's 2.4.
What if it wasn't
Can I
there?
use the Newton method?
If it wasn't there,
Hate situation.
I think it would be there. It's the answer to what if it wasn't there.
Oh, so you just no, but sometimes it says use a suitable stuff.
Okay.
Use suitable.
So you come up with use one, or you use, it depends upon the question, doesn't it? It depends upon the equation. But use something that would make some sense.
But what if you just don't really get it, you just do what you do every time?
Then use one.
It's not bad.
You'll only lose one match.
Alright, so we're going to start.
You know, you need to draw a graph and then you choose
2.4.
Yeah,
point
you
that
take one.
looks like it.
And actually, what matters first when we do this?
Exactly.
Oh,
I kept
Yeah,
making
been on
it
time.
move
Yeah.
like this time.
this is going to get a lot of views as this one.
I'm not going to put this one up because I can't even carry on without having to wait for this. This one, the first thing that we have to do, there's going to be a marker for this, is that x n plus 1. Remember how you have to turn it into an iterative formula
How do you know it's n plus 1?
to start with. That's just your way of saying that the next term is generated by using the previous term. And it's a valid question about what our start point is. It's always this. You always put the x on its own as being x subscript.
Is it always n plus 1?
Yeah.
You can never just xn.
No, it's got to be that the next term is some formula involving the current. And our first value, x1,
And you have to
is
do like
2.4.
two iterations.
And this is yours.
Really? It's like why
We're doing the iterative
That's
process.
quite good.
Just, this is so easy to get your calculator to do all the work.
You just change that
Just
to
in
an
case
iterative
you
form.
can't remember how to do this. This is the reminder. Everybody knows how to do this on calculator, don't you? Do you?
Yeah.
To do what?
Yeah.
Yeah.
For the answer in an answer.
You start by typing in your first value, so 2.4, and pressing equals.
Wait up.
And then once you've done 2.4 and equals, you put in your iterative formula. So it's the cube root, which on most things you've got a cube root bottom, and it's 16 over 3 times ants. And so you put 16 over 3 ants plus 1, and make sure that's all inside the square root sign. And then very carefully press equals just once. And that gives you your first answer, which is 2.39861. We're wanting our answer to 3 decimal places. So I'm going to make sure I put plenty down to see when it's converging. And then we press equals again, making sure that we don't get carried away with this. Because we're going to have to write down every single value, 2.39818. I want this, I want to keep going until my answer to 3 decimal places has settled down to be a consistent fit in. At the moment it's changed. 3 different places, it's been different each time. 2.4, 2.399, 2.398. My next one, 2.39805. Now, at this point, I am pretty sure, because it does look like this 4th decimal place is going down. But even if it goes down a little bit further, it's still going to round to 2.398. It doesn't matter if you put an extra one down. 2.39801. I think at this point we can be pretty much certain that x equals 2.398. 3 decimal places, and the question said find the coordinates of P, so what do we now need to go back and do? Put it into the original equation, the y equation, which is quite a complicated thing. Right up at the top, 3x plus 4 over x cubed and 4x squared plus 2. Was that it? And so we put that answer in. And I've got minus 1.552 out of that as my x and y values. Alright, are we happy with that? They want you to get at least 3 iterative values. I wrote down 4, but they wanted to see at least 3 iterative values there. Okay. It's another thing, mathematically, there's really not that much difficulty, especially in this second part. That you could have got tied up in knots in part 1 and not arrived at that. Your differentiation could have gone hideously wrong. You could have ended up without that answer. But when you come to part 2 here, you've got a clean start, so you can go straight in and turn that into an iterative formula, throwing 2.4 into it, doing your 4 iterations, 5 iterations, and then subbing that value into the y equation. None of that was any kind of high-level stuff, and that was 5 marks for the second part. So it's also, there's got to be something about you being aware that even if you make a mistake early on in something, don't give up on a question because of it, but you can often salvage a lot of marks later on. Okay. Are we still doing alright? I now have to